we have found a relation between the pressure of the gas and its density and averaged velocity. Now, but at this point, we need to understand this average velocity a little bit more before we can go on to the next step. Now, this average velocity is not actually velocity as in the overall actual velocity of the molecule. If you remember, u is just one component. It's just a component along this direction. Okay, but the actual velocity can be in another direction. And usually it would be in some random direction. So we now need to relate the averaged u squared to maybe the average overall velocity, and that is a little bit tricky. So I'll do that now. Okay, let me clear this up. Okay, I'll write down what I've obtained. I've obtained that the pressure is equal to density times the average of u squared, where u is the velocity of a molecule along one direction. Now I want to relate it to the overall velocity, okay, because that seems more direct. So let me draw this out again to try and understand better the relation between C and U. So that's the mass M, and I have C in some random direction, and I have U along this direction, U. Now, but actually I also have other components, right? This is just one component in this direction. So maybe in the vertical direction, I have another component, say V, and then in yet another direction, maybe the other horizontal direction, I have yet another component, because this is in 3 dimensions. So and the relation between this and each of this, okay, is we can actually obtain using Pythagoras theorem. Now let's see how we can do that. All right, we might imagine that if I project this down to this plane, project this point down to this plane, I will get a vector like that. Okay, and this vector here would be related to those two components by a rectangle like that. So I can actually find this vector, find the length of this from U and W. The W is the component along this direction, using Pythagoras theorem. Okay, I just need to do U squared plus W squared, and that will give me the square of this. If I then take the square of this and add to the square of V, I would get C squared. So this gives us the answer already. Right? So C squared is actually equal to the square of V So let's say v squared plus the square of this. Okay, that's because if I drop a perpendicular from there to v, this would be also a rectangle. Okay, so v squared plus the square of this is c squared. Now the square of this we can obtain from these two sides using Pythagoras theorem again. So that will be u squared plus w squared. So w squared plus u squared. So this basically is a 3D Pythagoras theorem. Now, as I said, I want to relate u squared average, the average of the velocity in one direction, to the actual velocity, which is c. Now, if you look at this, you see that if I imagine taking the average of c squared, it would be the same as adding up the averages of each of these individual velocity squared in each of these directions. Now, but I can think that these three directions, if I look at the gas in the box, all right, if I look at the three directions, now we can imagine that the three directions, there's nothing special about one direction that makes it different from another direction. Since the motion are all random, the average velocity squared in one direction should not be different from another direction. So we would expect that the average of all of these should be the same, because all directions just look the same. Okay, a gas don't look different in one direction or another. So therefore, the average of c squared, right, since the average of all those are the same, right, I can just take an average of all of these, and these are all the same, so I can just say that it's equal to 3 times of one of them, u squared bar. And now I have a relation between u squared and c squared. U squared is just, bring the 3 over there, it's just 1/3 c squared. So therefore, finally, I have the expression that I want. Pressure is equal to 1/3 rho c squared. So this is an important relation, relating pressure to the speed of the molecule.